Okay, so the next set of notes are the aufbau principle notes, and it's as the atomic number increases, electrons are added to the orbitals with the lowest energy first. So we have a big number, we have it radon, and it's 86. So we have to do 86 electrons, that's a lot. So we're going to start with the lowest energy level, which is 1s. So we're going to have 1, 2, then we go to 2s, 3, 4, then we go to 2p. So this is 4. I like to make little notes of how many I have just in case I lose count. So remember, I have to do one at a time up here. I have to do all ups. So 4, 5, 6, 7, 8, 9, 10. Okay, so we got 10 here. Now we go to the 3s level. 11, 12. Now we go to 3p. 13, 14, 15, 16, 17, 18. So that's 18. Now, this is the next energy level. 3p, it goes to 4s and then 3d. This is actually how the energy levels are gauged. So 4s is a little bit lower in energy than 3d. So we have up, down, that's 20. Now we have 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so we got 30 right here. Now the next level is 4p. So 31, 32, 33, 34, 35, 36. So this is 36. Now we have to decide if we're going 5s or 4d. If you look, 5s is a little bit lower than 4d. So we have 37, 38. Now we go 4d. 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. Okay. Now we have 5p. 49, 50, 51, 52, 53, 54. So this is 54. Now we have to go 6s. That's the next low energy level. 55, 56. Okay, right here. And then if you look, you have D and F. Sometimes these two are hard to tell the difference between, but F has lower energy than D, just by a little bit. So 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70. So this is 70. Now we do 5D. 71, 72, 73, 74, 75, 76, 77, 78, 79, 80. So this is 80. And then we fill 6P. 81, 82, 83, 84, 85, 86. So we just completed them in order. So now we have to list them. So we have 1s2, 2s2, 2p, and there's 6 electrons here. 3s, and there's 2 electrons on that line. Now we go 3p. We count the electrons. It's 3p, 6. Then we do 4s. So 4s, and there's 2 electrons there. Then we move to 3d. So we have 3d, and there are 10 electrons. Then we have 4p. 4p is going to be 6. And then you have 5s. 5s2. The level above that is 4d. So you have 4d, 10. Then you have 5p. For 5p, you have 6. Then you're going to have 6s, and there's 2 electrons there. Then we got to jump over here to the next lowest, which is 4f, and there are 2, 4, 6, 8, 10, 12, 14. 14. And then you have 5d, and you have 2, 4, 6, 8, 10. And then lastly, you have 6p, and there's 2, 4, 6. Goodness, look at all that. That is a lot. Okay, now radon is actually an noble gas, so we can do a shorthand for it, but they make us go all the way back up and do xenon. So they make us go back a whole layer. And when we do xenon, xenon is 54. Well, look, I counted 54 right here, okay? So that means that it started after the 6s. So basically, we have to pick up right here and count all of the stuff that comes after that noble gas. So we're going to say 6s2. Okay, then we got to jump over to 4f, 2, 4, 6, 8, 10, 12. 12. I can't count. 2, 4, 6, 8, 10, 12, 14. 14, sorry. And then go over to 5D, 2, 4, 6, 8, 10. And then go up to 6P, which is 6. Okay, so for a summary, electrons sorry guys, I gotta find my notebook. My brain is drawing a blank on these. Fill in the blanks. Okay, so electrons spread out within an orbital group if they can. And the guy who said this was Hund. Electrons occupy the orbitals in the lowest energy level. This is going to be aufbau, the guy who we did the paper on. 2 electrons in the same orbital cannot have the same spin. They have to be opposites. And this is the Pauli exclusion theory. You can use the periodic table to predict the number of valence electrons. And the electron configuration an element will have. The sections of the periodic table can be used to predict the electron configurations for most elements. There are some exceptions within the F and D blocks. Okay, and then the last thing that we're going to do is I'm going to attach a blank periodic table, and on this blank periodic table we are going to go ahead and we're going to label all the different blocks. Okay, so I am going to color code, and I'm going to do it really fast because I'm about to have to go pick up my kids from school. So if you don't have a periodic table, you can rough sketch this. Okay, the orange is the S block. Okay, now when you're doing the S block, you're going to have 1S going this way, 1S going this way. You have 2S, 3S, 4S, 5S, 6S, 7S. Okay, then you're going to have the D block. Okay, so the purple is going to be in my D block. Okay, for the D block, we're going to have 3D, 4D, 5D, and 6D. Okay, then over here, we are going to have the P block. So, for the P block, we're going to have 2P. Sorry, this pen's running out of ink. So this is 2P, 3P, 4P, 5P, 6P, 7P. And then at the bottom, you are going to have your F block. Okay, so the F block. So with the F block, you're going to have 4F, and then you're going to have 5F below that. And that will go into your notebook. Like I said, if you can't print the blank periodic table and label this, you will need to do a rough sketch and label it and color it as well.